Hello students, in this video we're going to learn how to apply the binomial theorem. I'll be providing you with different types of questions that you may be tested in the test or in the exam. Do get ready a pen and some papers and practice along with me. First, let's do a recap on the binomial theorem. For a positive integer n, we can expand bracket a plus b to the power of n using the theorem as shown on the screen. What you need to take note is the number of terms in the expansion of bracket a plus b close bracket to the power of n, it's n plus 1. What it means is if you're asked to do an expansion for bracket 2 plus x close bracket to the power of 3, you would need to end up having 4 terms. The number of terms is always one more than this value here. And the general term given in the expansion is this one here, where your r can be greater or equal than 0, less than or equal than n. This general term is very useful when we need to find a specific term. It could be the middle term, it could be the second term, or it could be the 50th term. All right, let's look at example 1. Example 1, we are asked to find the first 4 terms in descending powers of x for this expansion. Let's compare this expansion given with the theorem. And from here, you can substitute a to be x, b to be negative 1 over x. This is very important. If you don't substitute b to be negative 1 over x, then you won't get the correct answer. And n is equals to 6. So with all this information, now we can use the theorem to get our expansion. Right, so the first term will be a to the power of n, which is just x to the power of 6, followed by 6th one, x to the power of 6 minus 1, bracket negative 1 over x, plus 6th 2, x to the power of 6 minus 2, bracket negative 1 over x, close bracket to the power of 2, and one more term, which is 6th 3, x to the power of 6 minus 3, bracket negative 1 over x to the power of 3. And if you were to do the full expansion, we should be getting 7 terms. But we're not going to do that because the questions only require us to find the first 4 terms. Let's simplify further. X to the power of 6 is just basically x to the power of 6. For this, you can use your calculator to evaluate, and that will be, how do you do it? You have to press 6 first, followed by the shift key on the calculator. You will see this symbol called NCR, and followed by 1. So that gives you 6. X to the power of 6 minus 1 will give you x to the power of 5. Do the same for this term. So press 6, shift NCR 2, and that you will get 15. X to the power of 4. So for this particular term here, negative 1 over x times negative 1 over x, you will get positive 1 over x squared. So this becomes 1 over x squared. Again, use a calculator to evaluate 6, 3. So press 6 first, shift N0 3, you will get 20. 6 minus 3, x to the power of 6 minus 3 gives you x to the power of 3. And negative 1 over x times another negative 1 over x times another negative 1 over x will gives you negative 1 over x cubed. So there's a negative 1 over x cubed here. Right, let's continue some more. So I would have plus times a negative gives you negative. And you will have 6x to the power of 4. How do I get it? You will see that this term here will give me x to the power of 5 times 1 over x to the power of 1, and that gives you x to the power of 5 over x to the power of 1, right? And that gives you x to the power of 5 minus 1 give you x to the power of 4. All right, so we're going to do continue, so that this will give me fifth, that will give me x to the power of 2, 4 minus 2, x to the power of 4 over x to the power of 2. So it's x to the power of 4 minus 2 gives you x squared. This and this will gives you a negative. And x cubed over x cubed will gives you 1. So you end up just having 20. And that's how we do this simple expansion using binomial theorem. Let's look at example 2. In example 2, we are told that this expansion is equals to q minus 96x plus rx squared. And we're asked to find the unknown q, r, and p. So what do we do? Yes, we will have to apply binomial theorem to expand this term. And let me write down the binomial theorems on the screen so that we can just use it for our expansion. So if we were to do a comparison, we can substitute the values for a to be p. So that will be p to the power of 6. I don't think I need to bracket it because it's not a negative value. Plus 6 1, p to the power of 6 minus 1. Bracket it. Why bracket it? Because the values for b is negative half x. To the power 1 plus 6 2, p to the power of 6 minus 2, negative to the power of 2. And when do we know when to stop? If you look at what you're asked to compare with the expressions on the right hand side, it ends with x squared. So we know that we can just stop here because this will give us x squared. If we continue, the next term will be x cubed, which is not necessary. It's not what we want. Let's simplify. I would have p to the power of 6. If you use a calculator as what I have explained in the earlier slide, you can use a calculator to evaluate 6 1. That will give you 6 p to the power of 5, negative half x. 6, 2 will gives you 15. 6 shift n0 to, yes, 15. P to the power 4. And this term here, it will be negative half x with a negative half x, and that gives you 1/4 x squared. All right, we can simplify further. That will give us negative 6 times half will be 3. So 3p to the power 5x plus 15 over 4 p to the power 4x squared. All right, so this expansion, it's equal to q minus 96x plus rx squared. So from here, we can do some comparison. Can let this, and we will get 3p to the power 5x negative equals to negative 96x. You can divide by x on both sides, so you would have divide by negative also on both sides. You will have 3p to the power 5 equals to 96. P to the power 5 is 96 divided by 3, that gives you 32. And therefore, p is the fifth root of 32, which is 2. That means 2 to the power 5 gives you 32. It's just basically on your calculator, press 32 power 1/5. 1 divided by 5. 1/5. You will get 2. All right. So having found our p, we can go on to find q. So q is equals to p to the power of 6, which is equals to 2 to the power of 6. And that will give you 64. Yes, 64. And of course, let's go on to find the last term, which is 15 over 4, which is r x squared equals to 15 over 4 p to the power of 4x squared divided by x squared throughout. R will just be 15 over 4 times 2 to the power of 4, and that gives you 60. And that's how we do example 2. All right, let's look at the next example where we require to use the general term to find the middle term for this particular expansion. If you're going to expand all the terms, you will see that we will have 11 terms altogether. And therefore, the middle terms will be the sixth term. To get 11 terms, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, I have 12 here. Right, 1, 2, 3, 4, 5, 6. 3, 4. 1, 2, 3, 4, 5, 1, 2. Yeah. So the middle term will be the sixth term. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 8. 1, 2, 3, 4, 5. 1, 2, 3, 4, 8. So the middle term will be the sixth term. But we're not going to expand all of it just to find the sixth term, because we're asked to use this general term. This general term will help us to find the specific terms that we're interested in. So how do we do that? If you do a comparison again, you will see that we can substitute your a to be 2, your b to be x squared over 2, and n to be 10. So that will give us 10r 2 to the power of 10 minus r bracket x squared over 2 to the power of r. We will have to pull out our x term. So x squared over 2 can be written as half times x squared over 1. And that can be further simplified to be bracket half to the power of r times bracket x to the power of 2r. What I have used here is one of the rules that we've learned in the chapter on indices that will gives you a to the power n, b to the power n. Or if you have a to the power m, b to the power of n multiplied with z, that will gives you a to the power m, z, b, n, z. All right. So we have agreed that the middle term is the sixth term. And that means we're finding T6. So T6 is equals to TR plus 1. So therefore, R plus 1 is equals to 6. We will have to substitute R equals to 5 into this general form that we found to find our middle term. So T6 will be 10 to 5 to the power of 10 minus 5, half to the power of 5, x to the power of 10. Then 5 can just use a calculator to evaluate 10 shift and Sierra 5. That gives you 252. 2 to the power of 5 will give you 32. Okay, we can just use calculator to evaluate this whole thing so that we don't have to keep writing so much. 10 shift n 5 times 2 to the power of 5 times bracket 0.5 close bracket to the power of 5. That gives us 252. X to the power of 10. So this is our term. Okay, this is how we do it. Right, we're going to do the next part of the questions. That's part B. So for part B, we're given a different expansion. And in this part B, we're asked to find the term independent of x. So the term independent of x means x to the power of 0 term. So this is something that you need to remember. Independent of x means we do not want the x there. So it's a constant. So a constant can be expressed as x to the power of 0. So that is the term that we're interested to find, the x to the power of 0 term. So first is to use this general term to substitute our values of n, which is 12 here. Substitute the values for a, which is 2x. Now here it's very important that you bracket it because you are having two terms here, 2x. So it's the whole 2x, so the power 12 minus r. If you do not bracket it, then the power only belongs to x. which is not the same as having 2x to the power 12 minus r. And this is what we want. We want 2x to the power of 12 minus r. That's why you need to bracket it. It's very important. And the values for b would be negative 1 over x squared to the power of r. Let's use the same color. All right. Let's simplify. That will give me 2 to the power of 12 minus r, x to the power of 12 minus r. And I'm going to separate the negative from the x term. So that will give me negative 1 times x to the power of negative 2. 1 over x squared is equals to x to the power of negative 2. Why do I do that? I'll explain to you in the next step. I'll show it to you in the next step. That will give me bracket negative 1 to the power r times bracket negative, times bracket x, negative 2 times r, negative 2r. If you do not wish to do that, it's all right that you can leave it as 1 over x to the power 2r. But in the end, you still have to express it as a negative index. So you may as well change it to a negative index here. All right, the next step is to group all your x terms together. So this is very methodological. Okay, never mind. Sometimes we don't need to try so hard lah. All right, so that will give me 12 minus 3r. This is when I apply this rule. A to the power m times a to the power n give you a to the power m plus n. Okay, right. So we want to find the term independent of x. So that means we're interested to find x to the power of 0. So we're going to let x to the power of 12 minus 3r equals to x to the power of 0. So 12 minus 3r is equals to 0. R will be equals to 4. And in the event that you get a fraction for your r, that means something has gone wrong in your working because your r and the n are integer. All right, so when r is equals to 4, now we can, that means I can substitute r equals to 4 here. So we're actually finding the fifth term. The term independent of x is actually the fifth term. So that is 12, 4. You can use this one. 2 to the power of 8. Negative 1 to the power of 8. Sorry, negative 1 to the power of 4. And of course, you will get x to the power of 0. That's how we get r equals to 4, right? By letting the one color in blue equals x to the power of 0. So you can just use a calculator to evaluate that. And that gives you 1, 2, 6, 7, 2, 0. So this is the term independent of x. You see that there's no x. There's no x there, basically just a constant. All right, let's look at part C. So for part C, we can just use the general term we found in part B because the expansion given is the same. Right, so we can let x to the power of 12 minus 3r equals 1 over x to the power of 15. And of course, you can't do a comparison like that, right? So we need to change this guy to x power negative 15. So 12 minus 3r would be negative 15. 3r would be 27. R equals to 9. So therefore, the term, we are finding the 10th term. And that gives me 12, 9 to the power of 12 minus 9. Bracket negative 1 to the power of 9. And of course, I will get x to the power negative 15. Okay, but we'll just find the term, so we don't need to write this down. Find the term. Okay, so use the calculator to work it out. That will be 12 shift NCR 9 times 2 to the power of 12 minus 9 times bracket negative 1 cross bracket to the power of 9. And we have negative 1760. Right, so this is the term in x to the power negative 15. So this is how we use the general term to zero into the specific term that we're interested in. Let's look at the second last example. For the second last example, you're asked to find the term independent of x in this particular expansion here. What it means that if I were to expand 1 minus 1 over 3, 1 minus 1 over 3x to the power of 2, and this one can be easily done by using your algebraic identity. There's no need to use binomial theorem. You would get 1 minus 2 over 3x plus 1 over 3x times 3x will give you 9x squared. What the question means is, if I have this expansion to multiply with this one, there will be 9 terms altogether. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so if you were to do the expansion diligently, which I will not advise you to do that, okay? One of the term is what we're interested in, the x to the power of 0 term. This is what it means, okay? So we're not going to do that, but I need to write it out so they can understand what's going on. So to find so if you look at what we have, we have 3 terms here. So to get independent of x means this one I would multiply with x to the power of 0 term here, right? And this one here I would multiply with x term. Why? Because 2 over 3x times x. You see that the x and the x cancel off, give you 2 terms. Basically, independent of x means I want the constant term. Once you understand that, it's quite easy to do the questions. So this one here, I will need to multiply with the x squared term. Why? Because 1 over 9x squared times x squared will just give me the constant 1 over 9. So this is the crucial one. This expansion is the crucial one. Okay, I need to get my x to the power of 0 term, my x term, and x squared term. Right, so that means I need to use my general term, the general term formula that we learned just now, which is TR plus 1 equals to NR AN minus RBR, right? Okay, so N is 8. A is 2, 8 minus R, b is x to the power r. All right, so I need the x to the power of 0 term. That means I let r to be 0. So the t1 will be 8, 0 to the power of 8 minus 0 x to the power of 0. So that gives me 8 shift NCR 0 times 2 to the power of 8 minus 0. So that's 256. And I need also R to be 1. So that will be my second term. One zero two four x. And then the last one is when I let r equals to 2, that would be my third term. So that will be 1792 x to the power of squared. Right, so this is all I need. So now I can multiply them together. To give me, wait, I should not write like that. Would have 1 times 256 minus 2 over 3x times 1024x plus 1 over 9x squared times 1792. And that will give me 256 minus 2048 over 3 plus 1792 divided by 9. 1792 over 9. And that will give me 256 minus 2048 over 3 plus 1792 over 9. Give me negative 2048 over 9. So this is the term that it's independent of x in the expansion. Instead of having another example, let's try to do this question using the concepts we have learned from example 1 to example 4. And I'm sure you'll be able to get the answer, which is negative 224. So let's try.